Thank you, Sterling. I'm gonna go quickly on these are homework questions that I did. I just forgot to record, so I'm gonna go over it again. Find the derivative of this. I'm sorry about that. So those of you who are in class, I will take 3-4 minutes of your time to go over this. So I'm gonna bring the exponent up front and then reduce the exponent by 1, and then the derivative of the inside function, which is this, times the derivative of the inside function again, because there are two inside functions. Cosine is one of them, and then the angle 5x derivative is 5. So you can bring the multipliers to the front with the -1, and then you get -45. And then the other ones, you collect them the way they are, cos squared sine. So number 23 is quotient rule. We did this as a homework question too. So this is sine of 3 pi by t is 1u and 2t is v. So u prime is this. U prime is this. The derivative of sine is cosine of 3 pi by 2 by 3t minus pi by 3 times the derivative of the inside angle, which is 3. Okay, so that is not right. So this is 3, this is u prime, and this is v, this v. So times v, which is the denominator, minus the top times the derivative of the denominator. This is u v prime over v squared, right? So then all I did was I bring up the multipliers to the front. 3 times 2t is 60, cos of that minus 2 that, divide by 40 squared. And then because I realized there is 2 here, there is 2 here, there is 2 here, I thought I would reduce it. So I factored 2 from the top, and then that's what we get. Number 25, we did it in the last lecture. Last lecture is done on the last lecture. There is a recording of when I was doing this, so you can follow. So this is what we got. So the second one, section is derivative of other trigonometric functions, because on the first section we only need the derivatives of sine and cosine. So there are other, like there are 6 functions in trigonometry: sine, cosine, tan, cotan, secant, cosecant. So we are trying to populate more derivatives of the trigonometric functions. So we wanted to do the tangent. The derivative of the tangent, you can change the tangent into sine over cosine and apply quotient rule. That's exactly what I did. The derivative of the top is cos times the bottom minus the top times the derivative of the bottom, which is negative sine x, divided by the denominator squared. And when you do this, you realize 2 negatives make plus, and then this is an identity that we did in chapter 20, which is cos squared plus sine squared is equal to 1. This is equal to 1. So 1 over cos squared, but better written as 1 over cos x, the whole to the power of 2. And then that is actually secant of x. So it is secant squared x. So that's why I had the derivative of the tangent of u is secant squared of u du by dx. And we just did the cotangent, d by df cotangent. Cotangent means cos over sine. And then when you apply quotient rule again, the derivative of cos is negative sine times the denominator minus the top times the derivative of the denominator, which is cosine x, divided by the denominator squared. So here I've got negative sine squared, negative cos squared, and then I can factor the -1, and then I got the other identity again, which is 1. So it's -1 over sine squared x is what I get, but I can rewrite that as 1 over sine x squared with a negative. So that is negative cosecant squared. So the derivative of cotangent is negative cosecant squared. That's where we're at. So we want to investigate what the derivative of secant is. Derivative of secant, as you know it, is 1 over cos. So you still can apply quotient rule. The derivative of the top is 0 times the denominator minus the top times the derivative of the denominator is minus sine x over the denominator of square is that. So this is 0, this is then plus sine x over cos squared x. So this is better written. You can leave it like that, but it is well known by a different format, sine x over cos x times 1 over cos x. Or you could do 1 over cos x sine x over cos x. You know, these are the same. 1 times sine x is sine x. Cos times cos is cos squared. So except the writing difference, they are exactly the same. But what is this? It is secant of x. What is this? It is tangent of x. So the derivative of secant is secant tan. So the derivative, I should start. The derivative of secant x is secant tan. So I'm gonna have, I have added a fifth formula. D by dx of secant of u is secant of u tan of u du by dx. All right. The last one is cosecant. So number 6 is okay. Exercise. I will leave that for you. It's the same pattern. Exercise. Find the derivative of y equal to cosecant of x. So as an answer, you have to do what I did, but d by dx of cosecant of x, the answer must be minus cosecant of x cotangent of x. That you have to get this one. So minus number 6, d by dx of cosecant of u is minus cosecant of u cotangent of u du by dx. See, as you can see, the functions which start with the c have negative signs. You see, the derivative of cosine has negative, the derivative of cotangent has negative, the derivative of cosecant has negative. I think it's good to remember. It might help you to not to miss the negative sign. So all the functions with starting a c have a negative on their derivatives. Okay, these are the other functions. So I will do examples. But in section 1, section 27.1, we did product rule, quotient rule, and chain rule, or general power rule. These are the same. It's like u to the power of n, the derivatives n u to the n minus 1 du by dx, kind of, or all right. So we did all this. So I think the same thing will apply here. We're gonna have different functions, but the same application will be on those questions. We have a formula sheet. I will supply that. I mean, the derivatives. All I want you is to understand how to apply them to help you find the derivative. But these ones, I can give them to you. No big deal. Because this is technical math. So examples, I will start from, say, number 4. This is section 27.2, page 840. Number 4. Find the, well, the instruction is find the derivative. So number 4 is straightforward. But when you're learning it new, it's not straightforward. You have to learn it. So what we are given is tangent. What is, you go to the formula sheet, what is tangent's derivative? The derivative of tangent is secant squared. So your answer will be find the derivative of the function first, and then you will take care of the derivative of the angle later. So 3, the derivative of tangent is secant squared of the angle times the derivative of the angle, which is 3, in brackets, because you don't want to multiply it with this. You can't. So this is 9 secant squared of 3x plus 2 would be the answer. Did you follow me? Thank you. So let's do cotangent, like number 6. It has y equal to 22, cotangent of 2x. Then dy by dx is, first of all, 22 has no effect, but cotangent is what? The derivative cotangent is minus cosecant squared. So minus cosecant squared is a formula, minus brackets cosecant squared of 2x, the angle, times the derivative of the angle, which is 2. So it is minus 44 cosecant squared of 2x is the answer. So it's short, like two-step question. So it's very important that you know the derivative of each function. Okay. Number 8 is y equal to secant of root of 1 minus x. Okay, so the derivative of secant, you know, is, the derivative of secant is, you told me, or secant x tan x, right? So dy by dx would be secant of the angle times tan of the angle, according to this rule, tan of the angle times the derivative of the angle. What is the derivative of the angle? The angle is 1 minus x, the 1/2. What is the derivative of that? Bring the half up front, write the base, take away 1 from the exponent, times the derivative of the inside, which is negative 1. You got to do the details. Negative 1. So this is equal to secant of root of 1 minus x, tangent of root of 1 minus x. And this thing, I can reduce it maybe minus 1 over 2 root of 1 minus x. Or I can bring up front minus 1 over 2 root of, or, okay, 1 over 2 root of 1 minus x, secant of root of 1 minus x, tangent of root of 1 minus x. I'm sure in the book they might have written it like this, minus secant of root of 1 minus x, tangent of root of 1 minus x over 2 root of 1 minus x. They are the same. This and this are the same, except that you're not allowed to take out this. You cannot cancel them. You should understand that this number under the restriction of, or under the influence of secant function. This is not. They are not the same numbers to cross them out. You know, be careful. This is also under the influence of tangent function. Okay. So you will ask me if there is any questions. For sure, I trust you on that one. So if you're quiet, I assume that you're following me. Is that a good deal? Is that okay? I don't have to keep asking you, did you follow me or so? So hopefully you're following me if you're quiet. Yeah. That's it. That's it. That's right. All right.
Yes, sir, we're following you.
Okay. Thank you so much. All right. Number 10, maybe it is cosecant. So it gives me another function. I'm going to take it, h equal to 0.5 cosecant of 1 minus 2 pi t. You know, you go to the formula sheet. What is cosecant's derivative? It is actually minus cosecant in cotangent. So the angle is the same. So the derivative dh by dt is 0.5, has no effect. The cosecant derivative is minus cosecant of 1 minus 2 pi t, cotangent of 1 minus 2 pi t. That is the derivative of the cosecant times the derivative of the angle, which is minus 2 pi. Really, the derivative of 1 is 0. The derivative of this, your variable is only t. What's multiplying t? 2 pi as a number, right? So that's negative 2 pi. So here I can bring out this multiplier to the front. Minus 2 pi times 0.5 is minus pi, because 0.5 times 2 is 1. And with this minus, it becomes plus. This minus and this minus, they are all multiplying. So they become plus. So 0.5 times 2 is 1. So it's pi coming up front. Cosecant of 1 minus 2 pi t, cotangent of 1 minus 2 pi t is what I get as an answer. Okay, so we basically have finished all the angles, but I want to use chain rule, quotient rule, and product rule. At least one example for each, right? Technically, we're doing chain rule already. So, but what is y equal to 2 tan squared of x squared? See, so you might write this as such: 2 tan of x squared to the power of 2. That's exactly the same. So dy by dx is, bring the exponent, write the base, reduce the exponent by 1, times the derivative of the base. What is the derivative of tan? It's secant squared of the angle times the derivative of the angle, which is 2x. Chain rule after chain rule. 2x times 4 is 8x, tan x squared, secant squared x squared would be the answer. Number 14, or I can skip a few, but number 14 I will do. P equal to 3 cotangent squared of 4 minus 3r squared. Again, if you don't like this writing until you get used to, it's better to write the exponent outside of the cotangent. So 3 cotangent of 4 minus 3r squared, the whole squared. That's what it means. That's what they meant. So dp by dt, dr, is, bring the exponent up front, write the base, cotangent of 4 minus 3r squared, reduced by exponent by 1, so that's 1, times the derivative of the inside, which is, what is the derivative of cotangent? It is minus cosecant squared of the angle times the angle, the derivative of the angle. The derivative of 4 is 0, the derivative of 3r squared is minus 6r. So you can bring the multipliers. Negative 6r times 6 is 36r negative. With this negative, it becomes positive 36r. And cotangent of 4 minus 3r squared, and cosecant squared of 4 minus 3r squared. Okay. Now I want to do like a product rule. Number 20 has a product rule. Y equal to 3x times secant of 2 pi x. So dy by dx, you know, this is uv, u prime v plus uv prime. The derivative of the 3x is 3 times v, secant of 2 pi x, plus u times the derivative of secant is secant of tan of. So 2 pi x, tan of 2 pi x times the derivative of secant, the angle, which is 2 pi. If you forget that, you're losing marks for sure, because the derivative of secant of this is not this product only. The derivative of the angle must be multiplying it. So this is 2 pi and 3 is 6 pi, and I have what? Oh no, is there addition in there in between? Yeah. So I have 3 secant of 2 pi x plus I can multiply here 6x secant of 2 pi x tangent of 2 pi x. Well, I think this is good enough, or you can go 3 secant of 2 pi x is common. I have 1 here. I have 2x tangent of 2 pi x is also another answer. Am I missing pi? Yes, you're right, Wissam. So there is 6 pi. Here is pi. So 3 is then 2 pi. Is that okay now, Wissam? Or Arthur? Sorry. Yeah, okay, thank you. Thank you. So this is the answer. And we do a quotient rule, for example. Let's do like number 26. So y equal to tan squared of 3x over 2 plus sine of x squared. So dy by dx, the derivative of the top, please, now it gets bulky. The derivative of the top is 2 tangent of 3x times the derivative of tan, which is secant squared of 3x times the derivative of 3x, which is 3. The derivative of the top is this. Or think of it as tan of 3x the whole square. So bring the 2 up front, write the base, reduce 1, and then that's what you get, times the derivative of the inside, which is secant squared of 3x times 3. Times the denominator minus the top times the derivative of the denominator, which is the derivative of 2 is 0, the derivative of sine is cosine of x squared, times the derivative of the angle, which is 2x, over 2 plus sine of x squared, the whole square. This is a little bit lengthy. So what do I have in the first term? I got bring 2 or 6 tan 3x secant squared 3x 2 plus sine of x squared minus tan squared 3x, so minus 2x tan squared 3x cos of x squared over 2 plus sine of x squared the whole square. I wouldn't pull out tan x or 2 tan x from the numerator because there is no cancellation possible. So I could keep it the way it is. That's the answer. Okay. We can also use implicit differentiation. Let's do number 34, which I don't think I'll ask you, but you need to know x plus y equal to cosine of y squared. So what is the derivative on the left must be equal to the derivative of the right, right? So the derivative of the left is 3. Cotangent's derivative is minus cosecant squared of x plus y, right? Times the derivative of the inside, which is 1 plus dy by dx, if you remember implicit differentiation. Okay, that is it. The derivative of the right-hand side is the derivative of cos is minus sine of the angle times the derivative of the angle, which is 2y dy by dx. Do you all agree? Let me know. Did you follow me on that one? So I'm going to repeat. 3 has nothing to do. Okay, Trevor, I will follow you. I'll take you back. So, okay. So here is implicit. It's mixed up. When it's mixed up, we did it in section 23 like 23.9, I guess. Or so yeah, 23. Section 23.9 was implicit differentiation. So if they are mixed up, whenever you encounter y, you attach dy by dx with it, right? So the derivative of cotangent is minus cosecant squared of the angle times the derivative of the angle. The derivative of the angle, when you do so, the derivative of the angle is, the derivative of x is 1, no problem. The derivative of y is dy by dx, period. So now on the right hand side, the derivative of cosine is minus sine of the angle, but the angle's derivative is 2y dy by dx. Remember, whenever we find y, we attach dy by dx because we don't know how y is related with x. Okay, and then we have to solve for dy by dx. So here is what do we have here? So I'm gonna FOIL this. I'm gonna FOIL this to those two, right? So minus 3 cosecant squared of x plus y times 1, right? Minus 3 cosecant squared of x plus y times dy by dx, don't you think? Equal to minus sine y squared 2y dy by dx. There is nothing I can do in there. So I could bring this to the left and I can take this to the right. So sine y squared 2y dy by dx plus or minus 3 cosecant squared x plus y dy by dx, which will be equal to positive 3 cosecant squared of x plus y. Then I have a common factor here is dy by dx. That's the objective. So sine y squared of 2y, hold on. Where is this? Oh, I could have adjusted that. That's not right. A good write of this. I could have written this 2y. I could bring the front. So 2y sine y squared is better. So dy 2y sine y squared, but the negative is already positive when I transfer it to the left hand side. So 2y sine y squared minus 3 cosecant squared of x plus y is a common factor, which is 3 cosecant squared of x plus y. So technically what I'm going to do is, therefore dy by dx is simply this divided by this. 3 cosecant squared of x plus y over the big 2y sine y squared minus 3 cosecant squared of x plus y is the best I can do. Okay. Implicit differentiation always hard a little bit, like compared with the other methods, but I think you find them more often in trig functions, more often in trig functions. And unfortunately, this is a little bit hard, but nothing is new. Like it's a good practice for us to use the derivatives, rearrangement of functions, and so on. Okay. With this, I am done this section. So I think I'll take a break and then then I will start the new section. And I'm sure at least I will do 2 sections for the next hour. Okay, so break time. It's the right, instead of just opening up a new section, it's a right time to take a break, and then I will see you at 3 minutes past 11 maybe.
Sir, can you give us a homework for this topic?
I will give the homework. Yes, I'll give that homework. Not now, but while you're taking on break, I'll give you the homework. I'll search for the homework and then we'll do that. Okay, we are on break I'll see you in 3 minutes after 11. All right. Oh, Michael will be tested on implicit. I don't think so. No, but you need to know because when you do applications in trigonometric functions, you will find this kind of questions. They will say, "Oh, okay, what is a maximum? What is a maximum or x plus y plus 25 y equal to 7? What is the maximize this?" So you need to know how to find the derivative before you even consider maximization. Okay, so I think it's necessary. Okay, I'm going to look for the homework. So, but I will not specifically ask you for implicit on the test. It might come on the application, but not for the test. For your knowledge, I did that. Okay, let's see my homework questions. All right, Blackboard content. We're on break, so okay, first.